Hello everyone, welcome to JV Reddy Automation World. If you haven't subscribed to my channel, please go and subscribe to the channel, enable notification for more interesting videos. Today's topic is memoization. Very few people will know about it. Memoization in Fibonacci series. What is Fibonacci series? What is Fibonacci series? Fibonacci series, everyone knows it. What is Fibonacci series? Suppose we will add 0 1. First two numbers are fixed, 0 and 1. Third number, if you want to form the third number, we have to add previous two numbers, 0 plus 1 1. Now next number 1 plus 1, previous two numbers, 2, then 3, then 5, then 8. Like this, previous two numbers we have to add. This is called a Fibonacci series. This is a Fibonacci series. What is the use of memoization? We will see. First, directly we will jump into the program. And we will see. Fibonacci series. Okay. General way we will see how we will print in general Fibonacci series. In general. In general, how we will print? Suppose I want to print a length of 10 Fibonacci series, 10 Fibonacci numbers. First two things we will hard code it, A and B, 0 and 1. 0 and 1. Then we can print next 10 numbers. If we want n-2, whatever logic we want. Currently I am taking 1 to less than or equal to n. First print the A. A means 0. Next term, how we will get next term? A plus B. Next term, how we will get A plus B. Previous two numbers we want to add. Previous two numbers, 0 plus 1, 1. Next term will become 1. Now we will add B to A and then next term to B. Just a swapping. We are doing a swapping. I think everyone knows it. Fibonacci series, how it will print. Suppose if I print it, how it will print. See, 10 terms of the Fibonacci series, 3, 6, 9, 10. Exactly 10 Fibonacci series are printed. Suppose I want to print 50. 50 Fibonacci numbers. That's it. Within a very few milliseconds we are able to print it. We are able to print it. Same thing we will try to achieve in recursion. Okay. Same thing we will try to achieve this using recursion. We will create a one method. Recursion, using a recursion. Okay. What is the recursion? Recursion means looping, calling method itself. Calling method itself. What we have to do? If n less than or equal to 1, return n. If we pass, suppose 0. 0 means it should return 0 only. 1 means 1. If we pass 2, what we have to do? We have to add the previous two numbers. That means n minus 1, Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fibonacci of n minus 1 plus Fibonacci of n minus 2. If we add these two, we have to call this Fibonacci series again, calling same method again inside. It is called a recursion. Recursion method is calling method itself is called a recursion. Here how next number will form? Previous two numbers, if you add it to previous two numbers, it will form it. But the first two numbers we will return same as it is. If it is a 0 and 1, we will return. If we are passing a 2, suppose, we will get. Same thing we will try. I will comment it out this one. I will comment out this code and then we will call Fibonacci series. right? For suppose, right, I am printing 50, right? I am printing, first we will print the 10, right? 10 numbers. Okay, we will print the 0 less than 0 to less than 10. Alright, we'll see how it will call. We have to call the Fibonacci of I. How much time it will take? Let's see, within a very less time it got printed. First 10 numbers, right? We have printing, right? We have to take the n, right? N less than n, right? 50 numbers we want to print it. Let's see, it is still taking, it is still running. It is still running. Let's see, it is still running. Some point of time, if it reaches some point of time, it will give, right? We are pointing integer. What is the integer maximum? 4 bytes only it will store. Right? Still running. See, it is taking, right, longer time. It is taking longer time. Let's see, still not yet completed. It is still taking time. Right, based on your RAM capacity, right? It will based on your processors. Right, it is taking to calculate. It is taking still lot of time. Right, let me stop it. Right, not yet completed. After it will take maybe 2 minutes, 3 minutes. Right, it will take more time. Why it is taking more time here? Right, if you want to calculate, see, suppose why it is taking longer time. In the recursion, what it will happen, right? If you want to calculate, right, Fibonacci of 3. Suppose you want to calculate Fibonacci of 3. What we are doing here? Fibonacci of right, n minus 1 plus, right, Fibonacci of n minus 2. Right, we are doing this. Right, what it will do for 0 and 1, directly it will return 0 or 1. When it comes to 2, right, when it want calculate the Fibonacci of, right, 2, what it will do? 2 minus 1. It has to calculate n, right, Fibonacci of 1. Then Fibonacci of 0. Right, 0. Again we are calculating 0 and 1. Right, first we are 0 and 1, 2, right, 3, right, like this we are going to calculate it. Right, 0, 1, 2, 3, 4, 5, right, third number, fourth number, right, like this. What is happening here? If we want to, already 0 calculated initially, right, 0 and 1 we are returning n only, right, we are returning n if 0 and 1. Right, again see, Fibonacci of 1 is what? Again we are calculating. F of 0 again we are calculating. Suppose I want to calculate Fibonacci of 3. 3 means what? I have to calculate n minus 1. 3 minus 1, 2. Right, then again 3 minus 2 plus, right, 3 minus f of 3 minus 2 is 1. Here what will happen if you want to calculate f of 2? Again I have to calculate f of 1. I have to calculate f of 1, f of 0. Right, I have to calculate like this. Right, a recursive function this is. Right, we are already calculated 0, 1, 2, 3. Again f of 5. Suppose I want to calculate Fibonacci of 5 number. It has to calculate f of 4, f of 3, f of 2, f of 1. Again and again repeatedly we are calculating. Recursively it is calling. Already we have calculated f of 0, f of 1, f of 2. But still if you want to calculate, see, f of 50. Right. Again you have to calculate 49, 48, 47 like this. That's why it is taking longer time in the recursion. Right. Calculate because of what is happening method calling itself. It is repeatedly doing same actions again and again. So to avoid that one, what we can do? We can memoization. That means memorize. Already if f of 0 calculated, memorize it, what it is. F of 1 already calculated, memorize it. Don't calculate it again. Don't calculate it again and again. If it is already right? There, get from the memory. Get from the memory. Don't calculate it recursively. Right? That is the memoization. Right now, just we will see using memoization to optimize the recursive function. Right here, what we have to take here, we have to take the integer array, right? Integer array, or by using a simple way, if you want to take it as a hash map. We can use either a hash map or a hash table also. Right, memoization by using memoization using hash map. We can also calculate. Suppose if it is already there, suppose memo is already contained. If it is already there, return it simply. What is the value? Don't calculate it again. If it is not there, calculate the Fibonacci of n-1. We are passing this memo also. Right. If you don't want, just we will keep it as a just we will keep it as like here. We'll create the hash map here. Right. We'll create the map here. Just we need to change it as a static. Right, because it is a static method, just change it to static. Right, create the hash map and then verify. Before that, already value is contained here. What we are storing here? 0, 1, 2, 3 and the value of it. Value of the 0 or 1. Fibonacci of 0, Fibonacci of 1, Fibonacci of 2. Right, if it is already there, get from the map. Don't calculate it. Right, if it is not there, first time only it will calculate it. It will put in the map. If it is already there, it will not calculate. Now we will call this one. Right, instead of this, we will call memoization. Okay. Right, Fibonacci memo. Right, now same thing. We will take 50 numbers. Right, we will take the 50 numbers. Then we will see how much time it will take. Let's see. Very less time. Because here minus are coming. Why? Because it is a integer value, right? It is crossed the int size. That's why we are getting negative. That's why we have to change it to long. Right? We have to change it to long. Right? See, within very quick time. Right? Previously, right? It is took longer time. Right? Recursion. Now it is because of memoization. Simple change. We have taken the hash map and storing what is the output of these values. Right? We are storing it. 0, 1, 2, 3. What is the value of it? Already calculated one. We are getting that value from the map. If it is contains already, getting that value. Otherwise, calculate it. Right? Simple change within it reduced how much time it is. A lot of time it is saved. Right? Within a fraction of not seconds also, milliseconds. Right? See, very quickly it is executed. That is the power of the memoization in the factoring. Right? Whenever you get this type of interview question, maybe sometimes they will ask. Right? We can use this technique so that we can explain it. Right? They will impress it. Right? If you liked my way of teaching and the content presentation, just like the video, comment on the video. Right? Please share to your friends. Subscribe to the channel if you are not subscribed. Thanks for watching. Thank you.